We have discussed previously bromination of benzene using bromine and iron 3 bromide, and the product was bromobenzene. Can we do chlorination? And of course we can, and chlorination is actually carried out in a similar manner. Benzene reacts with chlorine in the presence of iron 3 chloride to give chlorobenzene. So this is a general scheme for electrophilic aromatic substitution reaction in general. And if we take benzene in the chlorination reaction, we react it with chlorine in the presence of FeCl3 as a Lewis acid catalyst, then chlorobenzene is obtained. And now if you look at the product here, the electrophilic aromatic substitution product, and if you look at the reactant, which is benzene, you can easily identify the electrophile that's required, and that's of course Cl+. So that's the key electrophile that's required, which is Cl+. So this is what we need to form mechanistically upon reacting chlorine with iron 3 chloride. Remember, iron 3 chloride is a Lewis acid catalyst which reacts with chlorine in a similar way that when bromine reacted with iron 3 bromide. So let's draw chlorine. This is chlorine and this is FeCl3. Remember, each of these chlorine atoms has 3 lone pairs, so therefore they can act as Lewis bases. So remember, this is the Lewis acid, this is of course the Lewis base, that's the Lewis acid. So there'll be Lewis base, Lewis acid reaction. The Lewis base, if you recall the definition, is a substance with a lone pair. A Lewis acid by definition is a substance that needs a lone pair. And of course the Lewis acidic center is iron, as we mentioned before. So we can move electrons from chlorine to iron like that, as indicated by this scaly arrow. And if you do that, then we get this intermediate. And of course, in this intermediate, this chlorine atom has now 2 bonds, and therefore it should carry a positive one or a positive formal charge. This intermediate then would undergo this chlorine-chlorine bond cleavage. So that Cl bond is broken, and if it is broken, therefore the electrophile required, which is this one here, is formed, plus FeCl4 minus. So this is the electrophile that we identified at the beginning, and this is how it's formed. Mechanistically, chlorine behaves as a Lewis base, iron 3 chloride behaves as a Lewis acid. That intermediate would give us the electrophile required, which then initiates the reactions. Benzene ring will now come in. It would react with the electrophile in a slow initial step, as we discussed before, to give this carbocation. Remember, there are hydrogens on these carbons. There is a hydrogen here, and of course this hydrogen here. Remember, this step is slow because benzene ring loses aromaticity, so that's why it's not fast. It's actually slow, but this carbocation intermediate would then regain aromaticity in a fast step, in this way, as shown electronically, as indicated by the arrows. The Lewis base, or the base, takes off that proton. Hydrogen-carbon bond is broken. A new carbon-carbon double bond is formed to give chlorobenzene as the final product in this chlorination reaction. So this chlorination reaction is another example of a halogenation reaction of benzene, when the benzene ring reacts with chlorine in the presence of a Lewis acid, which is iron 3 chloride. So a Lewis acid catalyst is essential again for the halogenation of benzene. For bromination, we use bromine iron 3 bromide. In the chlorination reaction, chlorine is used in addition to the Lewis acid catalyst, which is iron 3 chloride. The product is chlorobenzene. So this is another example of an electrophilic aromatic substitution reaction.